So here it asks, how much heat is needed to raise 4 kilograms of water at -4 degrees Celsius to water at 70 degrees Celsius? So what we need to do, right now we have water that's at -4 degrees Celsius. Well, water that is less than 0 degrees is going to be ice. So we need to, in order to get it to water at 70 degrees Celsius, we need to raise that ice up to the melting point. So the Q for our ice is going to equal mass, which is 4, times the specific heat of ice, and the specific heat of ice is 2090. Alright, don't forget that ice has a different specific heat than water. Alright, and then final temperature minus initial temperature. Well, the final temperature of ice is 0 degrees. Anything more than 0 degrees and it is water. It stops being ice. So minus -4, so this is actually a positive, alright? So 0 minus -4 is just 4. So let's go ahead and plug this into our calculator and calculate the heat that it takes to get this to the melting point. So 4 times 2090 times, and we can go ahead and type this in, 0 minus -4. Alright, and we get 33,440. Alright, and notice if we say 4 times 2090 times 4, it gives us the same thing. Alright, so now we need to melt our ice. Alright, whenever we are going through a phase change, heat transferred, we use this guy right here. Heat transferred during a phase change, which is Q equals mL. L being latent heat, or the heat that's needed to go through that phase change. Now the latent heat of fusion is whenever you're going from a solid to a liquid or a liquid to a solid. Vaporization is whenever you're going from a liquid to a gas or a gas to a liquid. So here we have the latent heat of fusion. That's what we're going to need to melt this ice. So I'll write heat for fusion. And this is going to be equal to, we just use this equation down here, Q equals M, which is 4, times L. The latent heat of water, right here, is 3.33 times 10 to the 5th. So we'll write that in, times 10 to the 5th, and we'll go ahead and put that in our calculator. So 4 times 3.33, you can use this second comma, and say e to the 5th, and we get 1,332,000. So 1,332,000. Right? Not to mention these are joules, because we're talking about heat energy. Alright, next, now we have water. Alright, we've taken our ice, we've warmed it up to 0 degrees, and we've gone through the phase change. So now we have water at 0 degrees where we left it. But we need that water to be 70 degrees. So we are going to use an equation for heat transferred during a temperature change, because we need another one of those temperature changes. So we're going to say Q equals mCp delta T. Well, our M is still the same, it's 4. And the specific heat of water is 4186. So we'll be writing in a different specific heat from before. And then our final temperature is 70. Our initial temperature was 0, because that's where the water started. So then we plug that into our calculator. 4 times 4186 times, and 70 minus 0 is just 70. Right, and we get 1,172,080 joules. Alright, so now what we do to find the total heat, Q total, we just add all of these together. Alright, so that's going to be our 33,440 plus our 1,332,000 plus our 1,172,080. And we get 2,537,520 joules. So this is the total heat that was needed in order to bring that ice, which was at -4 degrees Celsius, to water at 70 degrees Celsius.